Hello, ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we are going over section 3.2, Solving Inequalities by Addition. Yesterday we learned what inequalities were, so we don't have to jump into our definitions. Instead, we can skip over them and go ahead and start hopping along in our examples. The best way to learn about how to solve using addition is with some examples. Now, the examples that we are going to use are going to be super easy. All we're worried about is addition. And in addition with Mr. O'Neill's class means both addition of positive numbers and addition of negative numbers, which some people call subtraction. So what we're going to do is we're going to hop in and we are going to look at how to solve these. The first one that we're going to be looking at is x plus 9 has to be less than 15. Now, to solve means to get your variable on one side, means to get the variable on one side wow, this takes forever, and everything else on the other. So in this case, when we say everything else, I mean absolutely everything else. The only thing that needs to be on one side of this inequality is x, and every other thing needs to be on the other side. So let's take a look at what's hanging out with our x today. It looks like 9 is hanging out with our x. And we all know that 9 has a very tragic ending because 7 ate 9. But for now, 9 is still around and we are watching a prequel or something. So to get rid of this 9, we would of course do whatever we do to one side of an equation, we have to do to the other. That still holds true with inequalities. So if I want to get rid of the 9, I would subtract 9 or add negative 9. On the other side, I would have to do the exact same thing to keep things balanced. So we have x plus 9, and then plus a negative 9 gives us just plain old x on the left. And then on the right we have 15 plus negative 9, which would give us a positive 6. So by solving for x, we solve for x by getting rid of the addition portion on the left, which was a positive 9. We subtracted 9 to get it on both sides, to get rid of it on the left. When that happened, we were left over with 6. X is less than 6. Now we got to graph it. If I can draw a semi-straight line. There we go. Alright, so from before, we remember that we want the number that we're looking at right in the middle. So I'm going to take that 6 and I'm going to put it right there. I'm going to call this middle section number 6. And then I'm going to ask myself, okay, is 5 less than 6? And looking at it, 5 is definitely less than 6. So I know I'm going to go through, do I have a bar? No, I do not. So it's going to be an open circle at 6, and then I go through 5. And there would be the graph. Easy as pie? Absolutely. In fact, it is so easy it makes pi look pathetic. So let's go ahead and do another example. What happens if we have d minus 3 is greater than negative 6? Well, again, we want to get our x by itself, or our variable by itself. We don't have an x this time, we have a d. And then put everything else onto the other side. So the only thing that's hanging out with a d is the negative 3. So to get rid of it, we would add 3 to both sides. And when we get to that, negative 3 plus 3 is 0. So we have d plus 0. We don't bother writing the 0 down. And then we have negative 6 plus 3, which would be negative 3. And then, of course, we draw our graph. D is greater than negative 3, so I put my negative 3 in the middle. And then if I put 0 in, which would be somewhere over here, right? If I put 0 in, is 0 bigger than negative 3? And so that question is yes. Yes, it is. And so I know I'm going to go through 0 from negative 3. So if true, then through. Easy as pie? Yes, it is. Not to mention, pie is also a delicious and somewhat good for you dessert. So feel free to eat dessert as long as it is pie. Not pizza pie, because that's actually not that good for you, and it shouldn't be a dessert anyway. So let's look at our next one. Our next example is going to be 0.7 is greater than or equal to n minus 0.4. Now some of you are thinking, oh my god, it's on the wrong side of the thing! And like, no, it isn't. It's fine. Your variable can be on either side. It just happens to be on the right this time. It's because it's a right variable. Haha. Alright. To get the n by itself, we have to get rid of what's hanging out with it. In this case, 0.04. So we'd add 0.4 to both sides. Now when we do that, they cancel on the right, but on the left we have 0.7 plus 0.4, which is 1.1. So we have 1.1 is greater than or equal to n. And again, gotta graph it, so we put our little number line here. We put 1.1 in the middle, and we say to ourselves, okay, is 2 greater than 1.1? We're like, yes. Is 1.1 greater than or equal to 2? We would say no. So I know I'm going to go away from that point. Now the question becomes, is it a circle or a dot? We've got a bar. It's going to be solid. So we put a solid dot there, and it goes to the left. Still as easy as cake. So let's go ahead and go on to our next example. I know, so many examples today, right? Well, our next example is going to be a word problem. For an example, let's say that Billy Bob, who is related to Farmer Bob, which you can ask the pre-calculus class about him. Billy Bob has a phone that can hold 5,000 pictures. If Billy Bob has already taken 2,750 pictures, he really loves his goats and his cats and his dogs and his awesome bike that has like a giant engine in it that goes like 200 miles an hour down the road, except that it's a dirt road because he's Billy Bob. So if Billy Bob has already taken 2,700 pictures, how many more can he take? So if we're using an inequality for this one, we would say, all right, well, how many total pictures can Billy Bob make? And then that has to be something equal to or greater than or something, some relationship to the number of pictures he's already taken plus the number of pictures that he can take. So I kind of gave it away there. So number taken plus number left to take. So if he has a total of 5,000 pictures and he's taken 2,750 of them, what kind of an inequality sign should go here? Could he take just one more picture? The answer to that question is, well, yes, he could. Could he take 500 more pictures? Yeah, probably. I think so. Could he take 6,000 more pictures? No, he can't. So we know that the combined amount of those that are left to take has to be less than or equal to the amount that we have already taken. So we take our total, it has to be greater than or equal to the number taken plus the number left that we are going to take. And then solving for x, we would of course subtract 2,750 from both sides. And that would give us x is less than or equal to, see, 0, 5, so it's 250. and then 2,000 more. 2,250. So we have at most 2,250 more pictures that he can take. So Billy Bob can take at most 2,250 more pictures. Now notice how Mr. O'Neill answered that word problem question. He turned it back into a sentence and answered the question using English, not just math. I didn't say 2250 Pac-Man to the left bar X. That makes no sense to anybody, not even me. So what we need to do is when we're answering a word problem is to answer the word problem with a sentence. Answer it the way that you would be answering it to somebody that asked you the question. Like, for an example, hey man, I've got 4 gigs left on my hard drive. How many more video games can I get? And if you answer with just x is greater than or equal to 4, they'd be like, what? But if you say, hey, you can have 4 more games on there, then that would make a lot more sense to them. So make sure that when you answer a word problem, that you answer it with words. And that if you answer a purely number problem, that you answer it with purely numbers. All right, it has been a wonderful time. Let's go ahead and get to your favorite part, which is, of course, the homework. Yay, homework! Hopefully you guys have been good today. If you haven't, well, it's Thursday. Go home, rethink your situation, and realize that there's more important things to life than chatting in class, especially when you are given 20 to 40 minutes after class to chat while you work on your homework. Because I've got a saying, kids, when it's time to work, we work. When it's time to play, we play. Don't play when you still have work to do, and don't work when it's time to play. So I'm actually giving you the page number this time for some weird reason. I'm not really sure if it's on 179 or not. We shall see. But we're going to be looking at 1 through 5 odd, 11, 15, and then 17, 21, 23, 27, 29, and because word problems are super important, 31 and 33. So there you are. Get to it. Make sure that you do not talk while your teacher is talking. That's for one thing. Do not talk over the announcements. That's another thing. And please make sure to put my room back the way it was when you end your lesson. And as long as you're working, it's okay to chat. But as soon as you stop working, then it's not okay to chat. Stay in your seats once you have found a location. Don't throw anything away until the end of the period. Other than that, good luck and have fun.